Hey there, guys. This is a really, really sad case, and I don't know if we're going to be able to help these guys or not, but we're definitely going to give it a try. So this just got here today, and it just is a real tearjerker. Let's start with a note on this one. And since my eyes are so bad, let's zoom so that we can read the note together, and I'll read it same as you, right off the screen. In theory. Get focused. Come on. There we go. Okay, so this is issue description, and I know that we've talked to these guys on the phone for a while, so we know that that this was from an accident. This is an iPad 4. So it says, "Hello, my father-in-law went missing from a mountain hike last fall and was found late this summer, 10 months after, and his body was found." If that wasn't clear to Christine earlier today. So this is a guy that went out hiking, and he wasn't found until 10 months later. He brought this iPad, so this is the iPad. He brought the iPad to take pictures on this trip, but after 10 months in a backpack outdoors, it's dead, probably from water damage. We would like to retrieve the photos from this iPad in order to see the route that he took to end up where he was finally found. He would also use this iPad as a photo camera, and he did not back it up. So all the photos have sentimental value as such. It has been with the police in Norway since August now, and it just got here today, but they have not been able to retrieve anything. The police have contacted Apple. So even the police have contacted Apple, and Apple couldn't help them. Refused to help. This didn't even do anything. This is an unopened iPad. It's never been opened up. But I assume as long as it doesn't turn on, Apple won't do much more about it. My girlfriend and I are in New York and thought we could mail it if you believe there is any chance of getting anything off of it. I don't know if there's any chance of getting anything off of it or not, but it's definitely worth a shot. When something's so meaningful to someone, let's see what we can do. Let's at least try, right? So we're going to at least try. So this is a really, really sad case. This just showed up here a little bit ago today. I was actually going to stream a different device, but this one really was kind of tugged at you. So this one, I was able to just separate the screen. You can see that there's a lift. This is from the swollen battery, and that's pretty typical of what a battery will do to a screen. So without using any heat, I just ran a tool around here. This one was sent in from Sven Chen, and it's not quite as thick as our Magic Glass, so I prefer the Magic Glass, but for something like this is fairly disposable when you can just kind of like cut through here and cut this adhesive. All right, so all I've done so far is just kind of release this screen without using any heat. And let's see, is it released? It looks like it. All right, so this is LCD, and we'll take out the screws, and we're going to start with disassembly. And let's see if this stream is working. And we will see. Hi, chat. All right. I'm going to stay to mod this one. All right, so this one is really sad. Now, I think that this one is either, it clearly has water damage. I think that it's either going to maybe not have affected the logic board. A lot of times with iPads, when they just go in a bathtub or something, they will end up getting really ugly looking water, and it will sometimes just burn up the LCD connector, but a lot of times the logic board itself really isn't that bad. But I think that, with such a long time in the elements in Norway, which really, I don't think their weather is very temperate, it could have like software corruption where the ones and zeros are no longer as they were. All right, so this is what it looks like. This is bad. This is not a good looking presentation. So water definitely got in the LCD itself, and the battery is super puffy. Now this battery is completely dead. So puffy batteries aren't themselves dangerous, as we learned from our Apple certification. It's just the normal end-of-life state. And the logic board shield housings look pretty destroyed. Hopefully, not a lot of water actually penetrated these shields. If this was enclosed in a backpack, you know, I don't know. I'm not really sure an iPad 4 is going to be good with just the freeze-thaw effect, but we'll see. It's worth a shot. I really want them to at least have the peace of mind. So let's switch over and we'll see kind of what it looks like. It's amazing that Apple did not even attempt to do anything. Yeah, exactly. That's sort of the message, right? Maybe this is completely unrecoverable. But let's try, right? Let's be human beings, where this is clearly meaningful to this family. All right, so we've got this is what it sort of looks like under the microscope. Just really ugly looking shields. There's a lot of contrast. It's kind of head to toe. Water damage. All right, water damage. Let's go ahead and take it apart. So the next step, we're going to take this logic board out entirely and do some disassembly, and then we're going to see if we can get any life out of it. So let's see. That has a tragic title. Yeah, it does have a tragic title, and you really can't help with these cases. This is really sad. Like, I feel like crying right now. This was something that, like, I think that it's just got to be so difficult when you just want to know what happened. So apparently all I know is that Dad went out on a hike and didn't come back. And I guess that they found him nearly a year later, and he must have been in a surprising location. I would if it was my dad, I would just so want to know what happened. It would kill me. I just want to know what happened. All right, so let's see if we can get this guy taken apart. So we're going to just take the logic board out, and then we're going to clean up and correct any kind of obvious physical damage before we do anything else to it. Let's see if we can peel that off, peel that up, take the sticker off. And let's see, might be for the best that Apple didn't touch it and it got sent someone who knows what they're doing. Well, I'm honestly surprised that it's intact, that this has never been opened. I'm really surprised by that. All right. And there's some hope, at least, I think, that, great, maybe. Sometimes we've seen some really heinous saltwater damaged bottom of the ocean cases where a lot of times the salt water will instantly create a short to ground that will suck the life out of the battery really quickly, and that kind of can preserve the actual board in some cases. All right, let's see if we can uncrust the little speaker connector here and get that out. So that's really crunched in there. All right. This sort of stuff would send me running. Well, you gotta see what you can do. See how puffy that battery is? Like pillows. Okay, let's take the shields off. Now on the old iPad 4, these shields just are the easy kind. Remember this? The good old days where you could just take shields off just like that. All right, so from here, it looks great. I see a little bit of green, but it's not head to toe saltwater like I would think. All right. The board for an iPad is way tinier than I expected. Yeah, the iPad is mostly batteries, and this is an old iPad. So this board, if it were today, would be, fraction of the size. So this is an iPad 4, which is about as old as the iPhone 5. There's just a little bit of plastic covering the processor there. All right, looks like a mattress. Yeah, the puffy batteries Sure do. Now I can remember working on the iPad 4 way back when I first started. iPad 3 and iPad 4 were some of the ones that were out back then. So this is a little bit of a nostalgia repair, a trip down memory lane to remember where everything goes in the iPad 4 and what their classic problems are. Let's take a look and see how bad it is under the microscope. So we're going to turn off hand cam. And let's see. All right. So this is the battery connector on the bottom side. And I remember the backlight. There's 2 backlight lines in the iPad 4 where you would get that half-dim backlight if the LCD connector didn't have a latch. Anybody old enough to remember that old repair? And this was one of the sort of the easiest beginner repairs. Backlight filter replacement on iPad 3 and 4. This is the bottom side of the board. Looks pretty good. So there's underfill on those chips. There's underfill here. That all looks pretty good. And then we've got some green around this guy here, which I'm pretty sure this is the equivalent of the VCC main battery MOSFET in a modern device. I think we'll have to look that one up. So that guy has gotten some fuzz, and then this guy here this component there, we would want to look up and see what that guy is so that we would know whether to measure him. I'd really like to clean this board up and do some measuring around before we actually attempt to fire it up so that we can kind of see what's going on. All right, so we've got a little bit of green. Let's kind of look at that. This is an odd substance. It's light green and it looks like a gel. I'm not quite sure what that substance is, but this may not, I'm not sure if that's actual like green from corrosion, but it doesn't have that consistency. It looks like a liquid that itself may have had that color. I don't know what that would be. A gel or a lotion. Maybe that makes sense if it were in a backpack, that maybe there would be some kind of a gel or lotion product. Deodorant maybe, I don't know. All right, so we can see that we've got some of that kind of going on around the connector there. I'm going to just take off some of these stickers so that we can really get a good look at this entire board. All right, looks good under that sticker. We can see right here we've got just a little speck of corrosion. And let's look under this sticker here. Let's get the sticker off. Yeah, there's this more of this kind of the dull green. It looks like toothpaste almost. I wonder if that's a possibility. I wonder how, maybe if we could see the backpack or see where it actually came from, we might get a little bit of a hint on what that stuff is. Not sure that it's really important, just an observation. All right. We'll use this video for people that have said they would never let third-party repair shops touch their iPhones. Needless to say, my blood pressure gets high when I hear them say that. Well, you know what? Everybody has the right to make their own opinion and think for themselves. You can certainly have the opinion that you're never going to let a third-party repair shop touch your device. There's nothing wrong with that. As long as you're aware that that's your opinion and that you do have options. All right, so what do we have going on here? That doesn't look good. This is a really rust cover. I mean, this is corrosion, rust on a coil. Now that seems pretty specific, which means that that coil likely was active and got hot and kind of, caused that to happen right there. This is the charging coil here, which is looks pretty undamaged. So that tells us that he, didn't find a charger or have some sort of charging phenomenon going on, most likely. And then we see a little bit of this rust crud around. These are the two backlight coils. And I'd have to look up this coil. I want to say that it's for image, but I'm not really sure. I need to look that up. Backlight diode 1. Here's backlight diode B, which is right there. And then here's our old TriStar chip. And then we've got more of this green. I'm not sure. I don't think this is like corrosive green. I think this is a green liquid. I'm just really curious to know what it is. We see devices with, this is obviously orange juice, and this is obviously, some kind of kid's high C or Kool-Aid. But I don't know what's green. What's like toothpaste colored green. Maybe it is toothpaste. It kind of seems like toothpaste. All right. Would it make sense to have toothpaste in a backpack? I'm not sure. Okay, this is, I think, speaker amp, just from memory. Speaker stuff. And that's it for this. This actually looks fairly mild, fairly minor. So what we're going to do, I'm going to go drop this board in Ultrasonic to give it a bath. And then while that's going on, we're going to look up the coil and the little burnt guy on the back. We're kind of going to take an assessment on the schematic of what these things are. So let me go drop this in Ultrasonic, and I'll be right back. Okay, let's get a microphone. Okay, so eucalyptus gel. What's that? Eucalyptus gel? That's my guess, says Arlene. And let's see. This was True Blue Apple fan on an Apple show. The thing is that most of these people never see what third-party repair shops are capable of doing. Well, good third-party repair shops are pretty good, but there's some bad ones out there as well. So, Palmolive dish soap. I don't know. I just really want to know. I'm super curious. Let's go ahead and start looking up some of those components. So let's go to the schematic and let's go to ZXW. So let's actually start with ZXW. So this is I was actually surprised. I had to look up to see, does ZXW even have a board view for iPad 4? So here it is. It does. So here's the battery connector. And what we're going to look for, let's see, on the top side of the board by the power management chip, we found already charging coil, and we found backlight coil. And we saw some green a little bit around these guys, which just from clicking on it, we can tell that must be the main power rail because they go to the backlight coils. This guy, though, is the one that was really, really rusty. Who is this? This is L8111. So it's some kind of a coil, and we can see that it is connected to the power management chip on one side, and then it must be an output of the power management chip, and it's going to go who knows where. So let's go to the schematic and let's find out. L8111, who are you and what do you do? L8111 on the schematic. All right, so let's click away ZXW. L8111. Let's see if I can remember that for long enough to look it up. L8111. L8111. Is that the right guy? Yes. Tell me what you do. All right, so let's see what this is. This is the power management chip, and what we have here is just kind of like a bill of materials. Are there any like little notes? Nope. All right, where else? Here we go. There it is. L8111 is one of the buck converter coils that are used by the power management chip to drop the voltage down from main to whatever output. And L8111 generates an output called PP3V3 out. PP3V3 out. So PP3V3 out is going to be meaningful to folks that have come to Practical Board Repair School, but probably nobody else. All right, PP3V3 out. Let's see. There's nothing that really tells us that this coil is bad. It's just rusty, right? So we're just making an observation, and we're going to guess how would it fail. It would fail if it became an open line. But other than that, you can really chew up a coil housing, rust the heck out of it, and it probably isn't going to make that coil stop working. But let's just research anyway. So where does PP3V3 out go? PP3V3 out goes to, let's see, L8111, and continues on. And it changes its name. So it changes its name to PP3V3 NAND. It also changes its name to PP3V3 LCD. Now these are going to be power rails. And I've never been here before on the iPad 4, so I don't really know. This is completely just as open-ended for me as it is for you guys watching. So what does PP3V3 NAND do? We're going to guess that it's probably power for flash memory NAND chip. And indeed, that looks like it's the case. It looks like it's an input into this chip, and this chip is going to be the NAND. Let's see if it says NAND on the bottom of this page. It does, NAND. Okay, so power for NAND, and let's go back and see what was the other name of 3v3 out. 3v3 out. Go back. 3v3 out becomes 3v3 LCD. So let's follow that one, 3v3 LCD. This is just an AKA, also known as. So 3v3 out is also known as 3v3 LCD. And let's see, where does it go? Let's see, that might not quite be the same one. Let's check. That's not the same. Let's see. Here we go, 3v3 LCD. 3v3 LCD is a power rail that comes into this chip. Now this chip I recognize from the iPad mini. The iPad mini has this chip, and his name is Grape. And I remember that of all of these words that we don't understand, cumulus and mason and chestnut and Maui and Fiji, and why are they making all of these crazy names? Do they have any meaning? Is it just somebody's girlfriend's name? Like, what's the heck? This chip in the iPad mini is called, the lines coming out of it are called Grape, and somebody brought this up once on YouTube, that when you kind of look at this SLG5AP3, that kind of looks like maybe from far away it might say grape on that chip. And I always thought that was a really good theory, so we don't really know that for sure. And we got a donation that I hear from Super Chat. $40. Thanks, Paul. I appreciate that so much. All right, so let's a bowl full of cleaning solution that you put the board in. Yes, ultrasonic going in the back, which it sounds like it just finished. Hi, Lenny. There's Lenny Jenkins on the chat. So what does this chip do? What does Grape do? Well, let's look at it. Let's see if we can figure it out. So it looks like this guy is plugged into the wall here on VCC main, and we can see those D and S, which we think, D and S, that sounds like source and drain, like a way a MOSFET would work. So we're going to guess that 3v3 LCD is connected to and becomes an output here on pin 5, most likely. And that happens not all the time, only sometimes when this enable, LCD power enable, comes to the Grape chip and would then allow 3v3 LCD to go through that guy and come out here as an output. So now the output is 3v3S0 LCD, and it goes through a filter, and then it's going to continue on, and now it has changes its name, and it plugs in here to the display connector. And it might plug into the display connector at that spot that we also saw that first green right on the board. So maybe the green stuff caused a transient short to ground that maybe is gone now, but it kind of caused this sort of like excess electricity that maybe burned that up. I'm not really sure. All right, so how did we get here? We're researching what does that really, the ugliest looking spot on this board was that L8111 coil, which is part of the buck conversion system from the power chip to create this 3v3 rail that powers the NAND, and now we know powers the LCD itself, so image. So NAND and image. Now we don't know that there's a problem. We're just looking to match the physical damage with an understanding so that we can do some troubleshooting. All right, what else was really messed up in this device? Let's see. Who can remember the other sort of really ugly spot? I think on the back of the board. So let's take a look at the ZXW again to kind of get oriented and see what's going on over there. Grape, that's cute. Yep. Yeah, Paul's the man for a $40 donation. Yes, absolutely. Definitely appreciated. All right. So now we're going to look at ZXW to see that other bad spot. So it was back here, and remember there was the green MOSFET. So we'll look up Q8104, but the really like burned looking dude was kind of at the top. It was this guy right here. It was D5990. So D5990. Let's look up D5990 and Q8104. So D5990. Let's go back and hit the schematic. And let's see. I can't remember things for more than just a minute. D5990, was that it? There we go. All right, so there he is. D5990 is a diode that is connected to ground, which seem to be part of like ESD protection for a line. And let's see, what line are we talking about? We are talking about E75, so accessory detect. So this would be down at the charge port. And it is plugging into, who recognizes this guy? This guy, even with this weird description here that is like, what? If you look at E75, 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 TS, 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 these are all TriStar words. This is TriStar, even though it's not called TriStar. The chip is the other version of TriStar. Remember that? This is the those TS versions of TriStar. So yeah, so TriStar, this is a ESD protection diode. So what does it mean if that guy is really burned up looking? Not very much. Maybe it means that there was a little bit of water down at the charge port or something. I'm not really sure. That's guy's probably not gonna do very much. It's not gonna be a problem. And the other guy, Q8104. What was that? Q8104? Q8104, is the MOSFET, right? So Q8104 connects main with battery. So the battery power is going to go through this guy in order to generate the main power rail. All right. That is the majority of the physical damage that we saw on the board. So let's grab it out of Ultrasonic and let's get it back. I'm going to scrub it a little bit with a toothbrush and alcohol just to kind of replace the ultrasonic fluid with alcohol. Then we're going to come back here and we're going to look at it again and maybe just sort of replace some of the ugliest looking stuff just to be really, really cautious on this one before we see what happens when we fire it up. All right, be right back. Okay, let's take a look and see how we did. What is the failure mode of that diode? Short or open? Usually they fail open, so the same as not being there. And we can just knock him off to rule that out anyway. All right, let's see. Just reminds me, my 5th grade science teacher, who I hope was cool. A humble and intelligent lady that always encourages learning. Well, that sounds like a fantastic teacher. All right, let's get rid of schematic, and let's go back and now have another look at this board. So over here, we originally had, this is where we first noticed the green, and that is cleaned up really well, which tells us that it really wasn't green corrosion. It was dried toothpaste or something like that. All right, so then let's kind of look down around here. This was the really ugly looking coil. Now that's rust. That's frank rust. See that? That's still pretty rusty. And we might replace that guy because we know that even though a coil has a hard time just going bad, all it is a coil of wire, just to be safe, we know he's important, right? Because we just looked it up. That guy is part of the conversion of the main power rail that generates the power for the NAND and the LCD. So we really need that to be clean. Now we could just fire it up and see if we have 3v3 on the other side of this coil, but it might be easy enough to just replace that since it's really doesn't seem to be in harm's way to swap out. All right, so now we've got our little bit of corrosion on these backlight diodes. Looks pretty good. The backlight coils look pretty good. This is cleaned up really well. There was never very much going on here with speakers. Now let's check over here. All right, this MOSFET that used to look a little bit cruddy, it looks pretty good. And this little diode here, now it looks really good. All right, so this board looks really good. Let's see. It has inherited some 3 little dudes. Look at that, like the power of crisp exam. It has inherited 3 little dudes that are almost certainly from the ultrasonic brush. They didn't come off from anywhere on this board. So it has some hitchhikers. Okay, let's look around and see, did we overlook anything? Because this all looks really, really good. And I actually don't like boards that look really, really good because really, really good boards often mean that they have some like data damage, corruption of the stored data itself, like we saw on the error 14 video that I just did recently. All right, so this one really, the only thing that I'm really going to do is I'm gonna take off this coil and just swap it out, just to rule it out, because that is really important. And here's the thing, I have seen precedent before. If you drop the 3v3 outline in an iPad mini, so if you've got 3v3 out powering the NAND and you drop that, you sudden short to ground just by accident, it will corrupt the NAND. And I've seen that before. So that's that's sort of what I'm worried about here. So I definitely don't want to risk it on this one since this case is really important and I want to give them the best chance. So I'm going to go ahead and replace this coil. I have a donor board here that it's really easy to just swap that out. So we're going to do that before we attempt to power this one on. So we're going to change L8111. All right, Hitchhiker's board has hitchhikers. Well, he wasn't really a hitchhiker. He was a hiker. So the hiker's board has hitchhikers. All right, so how are we going to get this thing off? Well, this is next to an underfilled power management chip. So I'm going to come in here first with a alloy of, just regular 183 solder, and I'm going to rework these joints so that it'll be easy to come off. At least in theory, I am going to do exactly that. Maybe that's easier said than done. How long has this been going on for? Not very long. We have done an assessment of the board. We've looked up where the physical damage was, so we kind of have an idea of what to expect and what's not a big deal. And we've determined that even though this coil is probably okay, maybe, he looks physically really damaged, and there's not a whole lot of physical damage on this board. So we're going to go ahead and just swap him out because we know he's really important. Wow, look at how that heats up. Do you see that? That's a really interesting and odd effect. Okay, so now with this lower melt alloy, in fact, we may be able to just grab him off. Let's see, without having to put any hot air on here at all. Let's see. My mini hot tweezers keep banging into the iron and turning themselves off. Can you come off just by yourself? Can you do it? There you go. You can. All right, look at that power of the mini hot tweezers. All right, so now we're going to grab... Oh, look at that. Is that rust under there, or is that something else? There's red particles right here. I had a case last night where a guy filed a PayPal claim against me, telling me that I sold him a bad ZXW code. I don't believe that's true, so I tried helping him for back and forth emails for an entire week, trying to get him to follow the instructions exactly. And in the end, I figured out what it was last night. He had, instead of just copying and pasting the code that we sent, he was typing it out, and he kept seeing the 0 and typing a lowercase letter O, and you can't do that. And I just thought it was a good example of sort of the power of real precise observation. That's really good. I think your eyes are your best tool for this kind of stuff. So you can see that this coil was sitting on some nonsense. Just said, iPad Rehab, have you used Paul's board view software for iPhones now? Well, you know what? I just started the stream, and one of the things I did was I went close on the open apps. I have just paid Paul Daniels for the Flex board view software because my son Bailey is doing the MacBooks around here, and so he's learning MacBook board repair, which is super exciting. And I did a stream with him where his face is super bored the whole time, and he's just like a typical teenager. And we tried to get it set up, but we didn't have a code or a key or something. I couldn't find it. So no, the answer is no, I haven't. But I'm definitely interested and excited to see what happens when you have a English-speaking person that you can talk to who is helping out providing software tools. I'm very excited, and I have high hopes for it. All right, so now let's grab the donor one. So we're going to grab this one here, and I'm going to just take this off with hot air. And this is going to take a lot of hot air because it's an iPad, and iPads are giant heat sinks. Just join the stream. What happened to the hiker? We don't know. That's kind of the reason why this is such a compelling story. All we know is that Dad went out hiking and he didn't come back home. And then 10 months later, they found him, and this iPad was in his possession. So the family is really hoping to answer that question. And I can't imagine how hard it would be to just not know what happened. All right, so we're going to heat this up and get this coil. And this one's just the donor board, so we don't really care that much about it. We just want to make sure that we get the coil off in a way that he's still in good shape. And it's really tough. Look at that. He's really stuck on there where everything else is ready to go. We can move these guys, but not the coil. Now, in these coils, they don't really like to be manipulated that much. So I don't want to just kind of try to take him with the hot tweezers like I did the other one, because I might do that, but I kind of thought he would come off by now. It's possible that there was that maybe this line was short. And I don't want to stress that too much. I'm going to go ahead and use a different strategy. Let's stick some of an alloy on here of a lower melt 183 to make it a little bit easier for that guy to get out of there in a way that he's not damaged. All right, let's try it again. Those damn coils love to stick to the board. All right. Hot tweezers do not come with bent tips. Nope. So this one might have like a touch of underfill or something. This is abnormal for it to be this attached. Yeah, he's just disintegrating. Boop. I wonder what made him so stuck. Like that he's just like glued to that. Let's kind of look at the pads. We'll have to go grab another one. Don't know. All right, let's do strategy B. That guy was really stuck on there. All right, I'm going to grab this other iPad 4 that I was using to charge up the test housing, and we will get him. Usually when I'm taking a coil, I do like to just use hot air because I don't really like to mechanically manipulate them that much. For that reason, I don't like to pull on them. I like to just get them really liquid and then pop them off. This guy didn't want to do that. All right, so we're going to swap for a different donor board. You know, it's really funny. Like I went to like try to find, Jess was bad-mouthing you. No, I'm not. I'm not bad-mouthing him at all. I said I couldn't figure out how to get Flex board view set up because I didn't know what the key was, which I'm pretty sure I asked him and he answered me, but I was already done by then. Alrighty, let's see. Maybe it was glued. Yeah, see, she wasn't bad-mouthing. See, falsely accused. All right, let's get the shield off of this one. And let's use a different strategy. So one thing that I'm a big fan of is with these things, don't beat yourself up to do something, sort of, it's got to go this way. No, it doesn't. There's lots of different strategies that you can use. I'm going to kind of get this shield out of the way because we don't need it, and it is going to draw some of the heat that I want to deliver to that spot. Just going to peel that out of the way a little bit on this donor board. So I just had, for years, I've had this little pile of iPad 3 and 4 and 2 donor boards that I use for whatever experiments. And I finally was like, nah, I'm never going to see one of those again. And I don't know where I put it. Put it in the vault somewhere. So I don't know. All right. Let's see. I did spend some time in ZXW the other day reading the case studies. And I really thought, man, that's a great resource that they're hard to understand, but they've come a long way. That I'm not sure that I would be able to figure out how to contribute to that. Do you know what I'm talking about? The ZXW maintenance cases, which is the word for repair. But those little case histories is a fantastic resource. And I'd really like to see something like a better repository of just that experience. You know, like this tends to go bad. We try to do that a little bit in It Takes a Village on the iPad Rehab Forum. But that would be a great project for a high school software somebody learning how to, do databases or something like that, to make a little, I don't know, widget that would just allow you to kind of query the device and, a line or a component or something like that. I think that would be really cool. The ultimate please bro solution. The ultimate please bro solution generator. Okay. Now let's see if we can take this guy off a little bit more readily. Let's grab a different tool. Let's grab some kind of an IC remover tool to try to get in there that we'll have at the ready. All right, let's see. Because I asked Jessa, has she tried the board view software? Not yet. Nope. All right. This channel is great. Well, thanks for watching. All right, now I also took away my Omnivice. Will I be able to find it? So much retiring of things. I had the Omnivice, which I used to use when I worked on these boards. All right, let's see if we can get this guy off. All right, so now we're trying to take off a donor board coil. I'm going to take this shield off because I think that is sucking up some of the heat as well. And I do think that there's probably a little bit of an adhesive that is keeping that guy on there. All right, so we can heat it up right here from the other side for a minute. Jim Parks is a professional developer, not a high schooler, but what needs built? Oh, well, funny you should ask, Jim. How about this? Why don't, while we're heating this up, take a look at ZXWs. This is what I'm talking about. So ZXW has an area called Maintenance Case, which we can click on. And we can see things like this guy talking about, one of them was really, really interesting. It was an iPhone 10 or something with error 4013. Was it that ended up being this like really odd failure? Where was that? Let's see. All right, let's just pick iPhone 10 cannot boot. So this guy is describing, yeah, this is going to be a description of a classic right next to the NAND, either a 3VO or a 1V8 fault. And so he's saying how he found it. Yeah, so he found like the single bad cap and then it boots. Right, so this is a little case. Yeah, 3VO short circuit of PP3VOS2 will cause this, right? That kind of information. It's difficult for people that speak English because this is a translation from Chinese, so it's really difficult. It would be cool if we had software where you could type in device, like iPhone 10, fault, doesn't turn on, or fault, no touch, and then see just reports of things that people have ever found that cause that to be the ultimate please bro solution generator. So if you want to build something like that, then send me a note because I think a project like that would be really, really cool. All right, let's get rid of ZXW and see if we can get this coil on here. All right, so it's kind of hot on that side. Now let's see if we can get it off. Yes and no. All right. Seems like a wiki would be a good match. Yeah. All right, let's see. All right, nice and easy. All right, so that guy came off way easy. And we're going to swap him right onto the board we're trying to fix, just like that. And this time, to put him on, I'm going to just use the mini hot tweezers, although hot air would be a perfectly fine choice as well. All right, let's see. Google Live Translate. Well, you used to have to use Google Translate, but honestly, you could kind of figure out what some of those meant just by looking at the pictures. You know, like a cave drawing, you know, it was kind of like that. All right, let's take a little bit of that solder away. Okay, so now we have prophylactically replaced the 3v3 out buck converter coil because we know that the one on there was really, 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 really rusty. And we know that 3v3 out, in our experience, can kill a device. So we don't want to take any chances trying to operate it with a really janky looking coil on there. All right, so now let's kind of look around and say, does anything else jump out at us, or are we ready to see if it will now turn on? So this seems to look really good. We've done ultrasonic cleaning, And the other sort of trouble spots, now they just don't look very bad. This one was this case where the green corrosion really did appear to be kind of a green gel or something. It was actually the liquid of the board. Okay, now we're going to see what happens when we try to turn it on. And this, I think, is really sad because it could be the end of the line. All right, so let's see. This is a test LCD that was recently working. So grab this test LCD that I know works for sure. And let's grab a test digitizer. All right, so we're going to put these two pieces together. And let's go to the hand cam. And we're going to see what happens. So we're going to try to put it back together. All right, someone should make a cave drawing of an iPad. Well, my husband made a paint by number of Mona Lisa holding an iPad, which has kind of been a fun thing. All right, so we could fire this up with DC power supply, which would mean that we would have to connect battery just by these leads here, which you can do. I have recently, just now, charged up this ancient iPad 4 housing so that the battery isn't quite 100% dead. So this is just an old one, iPad 3-4 test housing. Let's kind of rip that off so that that doesn't get into trouble either. All right. These are our test boards. This is our board. Okay. All right. I suspect janky is a northern term for Genlies. I don't know what that means. Janky. Janky. Like everything is just a little bit janky. Got to use a janky screen when you're trying to test things out. Okay. Let's... this is going to be sad. This is going to be sad. All right. Let's see what happens. Let's do a little bit of a light installation. So we'll plug in power button. We are going to keep it disconnected from the battery until very, very last. All right. I'm so old, my iPad was red and had 2 white knobs. Yes. I can remember this time of year, around holiday time, being a little kid, circling in the Sears wish book. Etch-a-sketch. And I would also circle the Snoopy snow cone maker, which I never got, and all sorts of other fun things. Uh-oh, somebody's iPad's going crazy. Somebody up front has a device with an alarm. Nobody's here right now. Somebody's got an alarm. All right. I'm going to touch it to the battery and hope that it doesn't actually have a short. If it does, then that short will get really angry. One thing I've learned with the iPads in general is they are incredibly sensitive to this connection to the battery. They do not like to be barely touching the battery. They like to have a really good connection. So if I didn't have this screw, then I would just hold it here. All right. It's not on fire yet, so that's good. I'm actually going to go shut that phone up before we turn this on and see what happens. All right, which one are you? This one. No, I don't want you to see. Feel really bad for Mark's life because I just know that when he comes up here to teach the course that he, like everyone, undoubtedly leaves phones that are going to have alarms set all over the place, and they're going to be really difficult for his poor wife who's left at home when he comes to teach up here. what does she do? And I asked him once, like, oh, does Cecilia, like, take apart things to be able to turn them off when they start to freak out? And he's like, no, she has a special, like, suitcase with pillows that she shoves them in until he comes back, which I think is pretty funny. All right, so that is ready to go. Now, the one thing about the iPad 3 versus the iPad 4 housing is that the battery is the same, so you can put an iPad 3 or an iPad 3 4 test housing, and then just apply whatever is the type of port for the device that you need. All right, let's see what happens. Oh, it's just so nerve-wracking, and it's just so sad. Okay, I'm going to prompt it to boot. Prompt it to boot. And we can see an Apple logo. And now, will it boot or will it boot loop? That's the question. How are the ones and zeros? How did the ones and zeros fare? 9 months in the wild, just out in the woods, on a hike of some sort, just exposed to the elements. We don't know if it will be able to actually be able to communicate with all of the ones and zeros in the flash memory chip and be able to actually execute a boot here or not. I think that we have solved all of the hardware problems. I don't think there's any other hardware. All right! It booted. Yay! Yay! This is great news. This is really good for the family. Now, the family has given me 2 passcodes, so I'm going to try to see. Oh, that is really, really great. All right, that is really great. I am going to try, and also very horrifying that this has been with the police who contacted Apple, who said, screw you, pal, we're not helping you. Ugh, that's just so aggravating. All right, I'm gonna see if the family's passcodes will work. All right, let's see. Oh, you can see the lock screen. Little cabin. Okay. Let's see, does it have touch? It does have touch. All right, take me back to the... Give me another crack at the passcode. I don't want to have to plug in the home button. Let's see if I can activate, get me back to the... How about this? Let's try slide to power off and cancel. Does that give me a lock screen? Oh, this is... I really, really hope that they have the right passcode. All right, let's see. Does that one even have a home button to plug in? No, it doesn't. All right, let's see. This is really, really great news. All right, passcode. All right, let's see. Don't go to sleep again. Don't go to sleep again. I don't want to mess it up. I don't want to get it wrong. Yes! They have the right passcode. Oh, God. All right, I'm going to take a look at this because I think it's too much to share. Oh, my gosh. So we are going to take hand cam off. And, oh, God. Oh, my God. Oh, God. It's not super meaningful to me because I don't speak Norwegian, but there are what they're seeking is here. Yep. So there's the last picture on there is of the hike. So we did take pictures of the hike, and we're there. I think they're going to be able to get that closure. I think this will be meaningful to them to know where this was, and there is 1, 2, 3, 4, 5. This is pictures of just total wilderness. Some of them are really beautiful. Oh my gosh, there's a lot of wilderness pictures on here, and And it goes back to that one. Oh, well, at least they're going to be able to get that closure they need. So I think this is really, really going to help that family. And I think that is it for this stream. Oh, this is so heartbreaking. It's just, you know, these stories are just so, oh, so sad. And I think this is really great news. And if you have a device and you've been told that there's no hope, you know, get a second opinion. This has been with the police for months. They're trying to figure out what happened to someone who died. And they ask for help from the manufacturer. Sorry, I can't help you. That's just really, really not cool. Thank you for watching. And thank you, Paul, for donating $40 to the stream. I really appreciate it. And we're going to get this one back into a state where we can recover all of this data. And then we'll be able to give them the call. And then we'll let you know if there's sort of a chapter 2. We may end up putting this together in an edited video just so that everybody can kind of have that piece. So that is it for this stream, and thanks for watching. Ah.